Okay, so we're going to pick out the information that we have for our example of Garth. He can row 5 miles per hour in still water. So that's basically his rate. So his speed in still water, okay, we already know what that is, and that is his 5. So we know what that is. We don't know what the current is because that is the initial question, which is how fast is the current. So we're going to let C be the speed of our current. Okay. Now what we're going to do is we're going to take our formula and we are going to set up what we call a table. And you're going to use this table for all of the motion problems that you do. Okay. So we already know what that rate is. So I'm just going to go ahead, and you can go ahead, instead of putting in the x, you can replace that with your 5. So our rate's going to be 5 in place of that x. Okay, so now we're going to go back and we're going to fill in. We already have our rates because we knew we were looking at the current and that 5 miles per hour in still water. Okay, the distance. What was the distance he traveled upstream? Upstream? Wasn't it 4? I think upstream was 4, wasn't it? Okay. All right, what was his distance downstream? 16. Okay, so there's our column for distance. Our rate. Okay, if he's going upstream, he's fighting the current. So that's his normal rate minus the current. He's going to fight the current, all right? And then going downstream, so going back the other way, it's going to help him. So it's going to be his normal rate plus the current. Okay. Now for our time, they didn't give us any information about the actual time, did they? They didn't say it took him 10 minutes to go upstream, 15 minutes to go downstream, right? So we are going to use our distance formula. We know that time is equal to our distance divided by our rate. Let me see if I can clean that up. So time is our distance divided by our rate. So going upstream, our distance was 4 divided by our rate of 5 minus C. And the distance going downstream was 16 divided by our rate of 5 plus C. Now, the wording of your equation was that it said it takes as long as upstream as downstream. So we're going to say that the times were what? It takes as long as him to go 4 miles upstream as it took him to go 16 miles downstream. So what do we know about the time itself? That the two are actually equal to each other. So we set up our equation where we take our two times and we set them equal to each other. So we have 4 over the 5 minus C equals our 16 over our 5 plus C. Okay. So you are once again back to our rational equations because of your equal sign, and we go through the steps that you have already learned how to do. The first step is to what? We find what? Thank you. We find that least common denominator. And step 2, then we do what with that? We go back and multiply. All right, so what do we have? Whoops. Multiply. What do we have? We have a 5 minus C here. And we have a 5 plus C here. So what is our least common denominator that's going to represent both of those? Yeah, both of them, right? 5 minus C, 5 plus C. So there's your common denominator. We're going to go back and multiply those then. So 5 minus C, 5 plus C over 1, and then over here. 5 minus c times 5 plus c over R1. So you have two little mini multiplication problems. Let's go back to the left-hand side. What's going to cancel?
5 minus c.
The 5 minus c. Okay. So that's going to leave you with 4 times 5 plus c. What's that going to give you?
C plus 20 over.
So well, it's going to be 20 plus 4c. It's not going to, the denominator cancels, so we're not going to have anything underneath it. Okay, on the right hand side, what cancels out? Okay, that's going to leave you with the 16 times the 5 minus c. That's going to give you a what? Okay, now solve that. All right, so in this case, we got that c equaled what? 3. Okay, and c, remember, was our current. Your initial question was what? What was the rate or the speed of the current? And that would be what? 3. Okay, so let's come back up here now. So going upstream right here, how fast was Garth actually going? He was actually going 2 miles per hour, and because he was fighting it, right? And then when he was coming downstream, how fast was he going?
8.
He was going 8 miles per hour. Okay. So you definitely have a disadvantage going one way, and you have an advantage going the other direction. Any questions on that? Okay. Okay, so we have two things working here. She is cycling against the wind, so we'll make our top row against the wind and our bottom one with the wind. So we'll establish that. Okay, and then we can fill in the information. How far did she cycle against the wind? 30. And how many with the wind? 66. Okay, so we got those for distance. Her rate, they told you that the speed of the wind is 3 miles per hour. Okay, so for our rate, this time, our last one gave us the rate in still water, which was the 5. They didn't give us the rate without the wind. So in this case, that's going to be your x. Okay, so if that's her speed, she's going against the wind, it's going to be x what? Minus, right? Against, minus. And this time they gave us that wind speed of 3. And then with the wind, it's going to be her normal speed or rate, what? Plus the wind. Okay, your time is your distance divided by your rate. So your first one is 30 divided by the x minus 3. And your second one is your distance of 66 and with the wind. What else do we know about the time? What they tell you? The same, right? Melody can cycle against the wind in the same amount of time that it takes her to cycle 66 miles with the wind. Okay? So how would we set this up? Again, this one's going to be equal to each other. So set those equal to each other. So the 30 over the x minus 3 equal to the 66 over the x plus 3. So we get x equal to 8, and we wanted with the wind, so you sub that back in. 8 plus 3 is 11. Okay. Let's look at one more here on here. Our next one is Elliot, I think. Okay. Okay, so here we have a situation where Elliot is in, I'm assuming his car, okay? and it is raining, okay? So he's driving. They tell you, how far did he drive while it was raining? 120 miles while it was raining, okay? And then the rain stopped. So here's your two situations. So we're going to label the top row while it's raining. Whoops, sorry. While it is raining, and then not raining. Okay, did they tell us how fast he was driving while it was raining?
20 miles faster.
While it's raining?
No.
No. They didn't give us any information about his rate on while it was raining. They did give us some information for after. So we do not know what his rate was while it was raining, so that will just be X. Okay? Okay, now, it stopped raining, then what did they tell you? He drove what? 20 miles per hour faster than while it was. So how would you show that using your X? X plus 20. Okay. So a little different setup. He's not fighting a current or a wind, okay? He was just going a certain rate, and once the rain stopped, he was like, well, I can go faster now because I won't skid or run into any flooding or anything like that. Okay, so the distance, we already said that. While it was raining, he went 120. What about when it stopped raining? 300. Okay? So fill in your time. So time for raining was the 120 divided by the X, and the not raining was his miles of 300 divided by his X plus 20. What was the other information they gave you about time? A total of 10 hours. If Elliot drove for a total of 10 hours, how fast did he drive while it was raining? So are we going to set these times equal to each other? No. We're going to do what this time? And make them equal to 10, add them. Kind of like our work, right? So we're going to add them together, and the time in the rain and not in the rain was a total of 10 hours. So now you're going to have something a little different as far as your setup. Whoops, I'm sorry. X. 120 over X plus the 300 over X plus 20 equals the 10. And if you want, you can put the 10 over 1 because you know you are going to have to find your common denominator. All right, so least common denominator. You have an X here, you have an X plus 20 here, and a 1. What's going to represent your denominators? X times X plus 20. You're going to have to use both of them. All right, and go back and multiply. Let's see what you get. So common denominator of X times X plus 20. So here in your first one, it is the X's that cancel. What did you get when you multiplied the 120 times the X plus 20? 120X plus 2,400. All right, plus, now your next one, it is the X plus 20s that gets canceled. So 300 times X would just be 300X. Okay? On the right-hand side, what cancels? Nothing. All right, so you have to multiply the 10 times that common denominator of X times X plus 20. You have a couple of options. You can go ahead and distribute the X and then multiply it by 10, or what would be another option? What? You have a 10 and an X on the outside. Can we go ahead and multiply those two together first? You have 10 times X plus 20. So we could do what? 10 times X is 10X, and then multiply that times the X plus your 20. Now what is that going to give you? 10X times X, 10X squared, plus 200, 200X. Okay? This then is now a quadratic. How do we solve quadratic equations? We set them equal to 0. So what's going to have to be moved? What are you going to leave the same, and what are you going to move?
Most of the other stuff.
Your x squared is positive, right? So are we going to move the 10x squared? No, we are going to move all of this over. Combine your like terms. What's the 120 and the 300x? So you have 420x plus 2400. You're going to move both of those to the other side. So do that, and let's see what we end up with. Okay, once we move the 420 and the 2400 over, we are left with 10x squared minus 220, x, get that in there, minus the 2400. All right, what can you do with the 10x squared minus 220x minus 2400? X factor, I would do something before that. Yes, thank you. You can take out greatest common factor of 10, right? So if we do that, I'm going to swing up here at the top. I'm going to take that 10 out. That's going to leave us with what? X squared minus 22x minus 240. Okay. And now we are going to do what? Now we can do our what? X method. Let me erase some stuff here so we can do that over here. All right, so here's our X. So you have a negative 240 and a negative 22. All right, so we're going to factor that then. So we're going to have X minus 30 times X plus 8. We do have that 10 still. And we know that that is equal to 0. I can't get it in, barely. All right. X minus 30. When is that going to be 0? Positive 30. And when is the X plus 8 going to be equal 0? Negative 8. Okay? What were we trying to find? We were trying to find how fast did he drive while it was raining. Can we use both of these solutions for answer choice? No. Which one are we going to throw out? The negative, because our speed cannot be negative. So we'll throw him out. He's extraneous, right? We're not going to use him. And so we get that our X equals 30. We're going to come back over here. We get X equals 30. So how fast was he driving while it was raining? 30 miles per hour, right? Isn't that the rate? Wasn't your rate X while it was raining? So he was going 30 miles while it was raining, and then when it stopped raining, how fast was he going? 50. So your car and your train, so your distance, your rate, and your time. How far did the car go? How far did the car go? 300, and the train went 200. The rate of the car was what? X plus 20, because it was 20 more than. So the train was at the unknown of X, and then the car was 20 more than the train. So we set those up. The car travels in the same time that the freight train travels. So how did you set your equation up? They were equal to each other. So you had your car's time, which was 300 divided by the X plus 20, equal to the time of the train, which was the 200 divided by your X. Cross multiply, you got X equals 40. So that was the train. And so what was the car? 60. Okay. Any questions on that? Those look good as I walked around.